Now, after the theorems, let's just move on further towards the problem. And the question number 1 says, if the diagonals of the parallelogram are equal, then show that it is a rectangle. So we have to prove that it is a rectangle. So let us suppose if I'm just taking a parallelogram over here. So this is my parallelogram that I'm taking, which is nothing but A, B, C, D. I'm taking this as A, B, C, D. And let us suppose if I'm just joining its diagonal, because it is given to us that the diagonals are actually equal. So first of all, we can see over here that it is a given condition to us that the diagonal AC is nothing but is equal to BD. AC is equal to BD. So let us suppose if we'll just prove that that one angle over here is nothing but 90 degree, then definitely it will be proved that it is nothing but a rectangle. So hence we just have to prove that any interior angle is 90 degree. So we just have to prove that any interior angle is 90 degree. Then that will be a rectangle. So we just have to prove any interior angle is 90 degree in parallelogram A, B, C, D. In parallelogram A, B, C, D. So let's just start the proof of this one. Let's just start the proof as of this one. So first of all, as you can see over here, we are just taking the two triangles over here. So let us suppose if I'm taking the triangle in triangle A, B, D and triangle ABC. I'm just taking two triangles over here. This is my first triangle. This is my second triangle. I'm just taking the two triangles over here. So first of all, we know that AD is nothing but is equal to BC, because we know that the opposite sides are equal in a particular parallelogram. Furthermore, we can say that AB is equal to AB, AB is equal to AB we have because it is nothing but a common side. And furthermore, AC is equal to BD, which is already given to us in this question that the diagonals are equal. So hence, what can we say about the two triangles? That the triangle ABC is actually congruent to the triangle ABD. We have taken the very first triangle as ABD. So sorry, this is D, this is not C. So ABD is actually congruent to the triangle ABC. So let us suppose if I'm taking ABD over here. So since the two triangles are actually coming congruent to each other, it implies that angle A is nothing but is equal to the angle B. This angle should be is equal to this angle. It means that this angle of the triangle 1 is equal to this angle of the triangle 2 by CPCT. Now furthermore, what we have to show over here that any particular angle is 90 degree in this particular parallelogram. So it implies that since we know that AD is parallel to BC and AD is parallel to BC, and AB being a transversal, we know that angle A plus angle B is nothing but 180 degree, because we know that the sum of the interior angles on the same side of the transversal, is supplementary. We already know about this concept that their sum is always 180 degree. So from this particular concept, we can get the answer as angle A plus angle B is equal to 180 degree. Furthermore, we know that angle B is actually is equal to the angle A. From this equation, means from the equation number 1, we already know that angle A is equal to the angle B. So what does it imply? It implies twice of angle A is 180 degree, which implies angle A is nothing but is equal to 90 degree. So hence at the end we have proved that one of its interior angle is nothing but 90 degree, and if it is 90 degree, it implies that one of the angle in the parallelogram in the parallelogram is 90 degree, it implies ABCD is a rectangle. ABCD is a rectangle. So this is nothing but the proof of this question. So hence proved. So this is all about the question number 1.